Hello, my bomb blowers and module masters, and today I am here with another Keep Talking and Nobody Explodes modded module tutorial, and today I am here with the module RSA Cipher. RSA Cipher is a very mathematical heavy cipher module, where our end goal is to plug each of our numbers into this formula. Let's go ahead and get started so I can demonstrate what I mean by this. This module does not require any ad work, so we can get started as soon as we get our module.
There is only one perfect solution, but there are clues that will try.
This is RSA Cipher. It contains the defined variables of n and e. I'm going to note these down in the text field calculator. Get used to seeing this, as we're going to be utilizing this a lot. Now, these four numbers here correspond to the four letters of our word. So I'm going to write them down in my notepad. So the end goal of the module is to plug in 409, 211, and the other numbers in as C. We're going to take them to the power of D modulo n minus 1. And that corresponds to the alphabetic position of each of our letters in our word. Well, we have C, that corresponds to these numbers. We have N, that's just this number. But what's D? Well, to get D, we have to use this step. But this relies on lambda n. Well, what's lambda n? For that, we have to go to the first step. So, the first step is as follows. Lambda n has a formula of such. So prime 1 and prime 2, that's what it means by p1 and p2, correspond to the number n here is the product of two prime numbers, from 11 to 97. So it is our job to find the two primes, when multiplied together, equal 989. And there's not much of a better way to do this than brute forcing. The minimum number, however, that can be the multiple of the two prime numbers that are a multiple of this number correspond to the number divided by 100 floored, so it's 9. Well, 9 is not one of our valid numbers, so we can start from 11. And from here, I'm just going to keep plugging in prime numbers until I get a non-decimal result, which is this. So our primes are 23 and 43. We're going to subtract 1 from both of them, which is 22 and 42. And then we're going to find the greatest common denominator of 22 and 42. So how do we do this? Well, the text field calculator does have a greatest common denominator function, where you can just stick in the two numbers and it'll give you the greatest common denominator. However, you can do an alternative method. You can take the bigger number, modulo the smaller number, and this gives you a result. Which, for this one, is 20. We're going to take the right number of the modulo operation, modulo by the result of the last line, and that's going to give us a new line. A new result of 2. And we're going to repeat this process until we get the result of 0. At this point, the greatest common denominator is the number to the right of the modulo sign. So, this. And this is going to give us a lambda n of 462. Now that we have lambda n, we can move on to step 2, so we can get d. So we're going to set up 7 variables with these labels. A, B, Q, R. It says to use T1, T2, and T3, but in place of these, I'm going to use F, G, and H. So A is equal to lambda n, which I have represented as y in the text field calculator. B is equal to E. Q is equal to A divided by B rounded down, which is just the floor of A divided by B. R is equal to A modulo B. T1, or F, is 1, and T2, or G, is 1. T3, or H, is going to be T1 minus T2 times Q. Now I'm going to plug these into the text calculator, and this gives us numerical values for all of our numbers. For each generation, I'm going to note down the number of B, R, G, and H. And I write them out in a flat line like this. I take the first number, and I put it as A. I take the second number, I put it as B. I take the third number, I put it as F. And I take the last number, I put it as G. Which gives us more results. This is a typo, I apologize. So, we're going to keep doing this process. We're going to take the results of B, R, G, and H. We're going to put them in the same places, A, B, F, and G. And we're going to keep repeating this process until we get an R value of 0. So for this one, we have 4, 1, 2, negative 1, 1, 5. We start replacing, and then we get an R value of 0. Whenever you get an R value of 0, after you have replaced both A and B, our D is going to equal the number on the final line, the final number on the final line, modulo by lambda n. And to check, the product of D and E modulo lambda n should be 1, which it is. So this is confirmation that we have done the step right. And now we can finally decrypt our numbers. So, for each number, we're going to take, I'm going to put this in parentheses, the number to the power of D, which is 347, modulo n, which is 989, that's a modulo, subtract 1. We're going to do this for all 6 of our numbers. And the results of these operations are going to correspond to the 6 letters of our words. These don't look like they can correspond to alphabetic positions. That's because they don't. The text code calculator does have an integer limit, meaning it cannot handle numbers these big. Like 81 to the power of 347 is already way above what the text code calculator can compute. So we're going to have to find a different calculator that we can use to compute these numbers. If you're on Windows, the Windows calculator in scientific mode can handle these calculations just fine. As you can see, it gives us 7, which is golf. We get 1, which is alpha. These are just the alphabetic positions. Golf is the 7th letter of the alphabet, alpha is the 1st letter. Then we get a tango. Then the 8th letter is hotel. Then the 5th letter is echo. And the last letter is Romeo. Our word is gather. We submit this to the module. And that is a solved module. Now, not everyone may be on Windows, so let's try and find a different alternative to this. You can use Wolfram Alpha. You can't input it like this, since Wolfram Alpha is going to treat the percentage sign as an actual percentage and give you this number, which is obviously not what we're looking for. So we're going to have to format it a little bit differently. So the modulo operation actually consists of putting the word mod in front of a pair of parentheses. The first number is going to be our number that we're taking, the modulo of, which is the number that was on display, to the power of whatever D was. Then we're going to put a comma here, and then we're going to take the number that we're moduloing by, 989, and then subtract 1. And when we put this into Wolfram Alpha, we're going to get 7. For the other numbers, just replace the number that's being taken to the power of whatever with the second number in the list. So 211 here, we're going to get 1 again. Then we just take 226. We're going to get the 20. Then replace this with 81. We're going to get 8. And as you may imagine, doing this will give us echo, and doing this will give us bromine. Let's do this one more time. We're going to put N, E, Y, and E. So for this module, our N is 6059, our E is 965, and our numbers are 2766, 4749, 1692, 2370, 5121, and 2286. So first things first, we find the two prime numbers that, when multiplied together, equal 6059. Once again, we can divide this by 100, and this is the minimum number that can actually be one of the prime numbers. 60 is not prime, so we are going to go ahead and start from 61, and we're going to go from here. And our two prime numbers are 73 and 83. You may have noticed me putting in non-prime numbers like 69, but no matter what happens, when you put one of the two prime numbers, you're going to get the two answers that correspond to the prime numbers we're looking for. So the numbers we have are 73 and 83. We're going to subtract 1 from them to get to 82 and 72. We're going to take the product of that and divide it by the greatest common denominator of the two, which is going to be, I'm sorry, this is not a 2, it's going to be 2. Or if we did the other way, this gives us 2. And then the result of this is going to be lambda n. I'm sorry, the result of this is going to be lambda n. And now we get our 7 variable step. A is equal to lambda n, B is equal to E, Q is equal to floor A divided by B, R is A mod B, F is 0, G is 1, and H is F minus G times Q. I'm going to take the result of B, R, G, and H, and I'm going to put them in the slots of A, B, F, and G. And then we keep repeating this process until, once we put in A and B, R equals 0. So let's keep doing this. We get 57, 53, negative 3, 49. This is not 0, so we keep going. 53, 4, 49, minus 52. 4, 1, minus 52, 725. And now, A modulo B is equal to 0. So our delta n, our delta even, is going to correspond to this number, modulo lambda n, which gives us 725. We can double check if this is the correct number. D times E. Modulo y should equal 1, which it does, so we have our correct number. And now we fill in the equations. Let me just copy this. Alright, so we're going to take this to the power of D, modulo by n, and subtract 1. And we're going to do this for all 6 of our numbers. And I'm just going to use the Windows calculator this time. I'm not going to use Wolfram Alpha, but I have shown you how to use Wolfram Alpha if you need to use Wolfram Alpha. But you could use the Windows Scientific Calculator to get the numbers just fine. So we get 8, which is hotel, 1, which is alpha, 14 is November, 4 is delta, 12 is Lima, and 5 is echo, which means our word is hotel, alpha, November, delta, Lima, echo. Thank you for watching this tutorial, and have a nice day.